Okay, welcome everybody. I'm Stephen Lewandowski. I'm here in my capacity as the chair of the Communications Committee of the Psychonomic Society. My only job today is to introduce our speaker and our moderator for the first One World colloquium of this season. Our speaker is Barbara Tversky, and our moderator is Beatrice Kuhlman from the University of Mannheim, who will be moderating the Q&A at the end. And we hope that there will be plenty of time for questions after Barbara's talk. Now, it's always difficult to introduce a speaker who doesn't require an introduction, but I'll try it anyway. And one of the things that is so striking about Barbara's career is that she's made contributions across such an incredibly broad range of areas, from memory to categorization, storytelling, gestures, design, creativity, and of course, spanning all those domains has implied that she's incredibly interdisciplinary and has worked with linguists, philosophers, neuroscientists, to name but a few other disciplines. She was the president of the APS, the Association for Psychological Science. She's a fellow of various learned societies, and she has held positions at Hebrew University, University of Michigan, Stanford, where she is now professor emerita of psychology. And I believe she's also at Columbia Teachers College. So, with that, it's time to hand over to Barbara. Thanks so much for talking to us. You might want to unmute yourself.
Okay, thank you for that introduction, and thank you for the invitation. I'm very happy to be here. Psychonomics played a huge role in my career and in my life. It was the first conference I attended as a graduate student with great excitement, seeing all the great names that I'd read about and revered. And I've been attending Psychonomics more or less regularly until the pandemic. So I'm extra pleased to be here. I was on the board also a number of years ago. So I'll begin. I have way too much to tell you. So I'll jump from topic to topic. A lot of this is written, not all. So there are other sources. So I'll begin. And I should say, in case you can't hear, I have a horrible cold and there are workmen outside my window. So this is life. So all creatures must move and act in space in order to survive, even viruses. And wait, I'm not finding the event. Yeah. So my rather audacious claim is that all thought begins as spatial thought. And I've gone into this in great detail in the book whose cover you see in front of you. And it's an interesting forest trees sort of design of the cover. I had nothing to do with it. Some people see a person running, some people see a network. It's meant to be both. So space is special. It's supramodal, not just visual, but auditory, touch. All the senses contribute to our orientation and knowledge of space. It's, as I said, essential to survival. If we didn't know how to get food into our mouths and back home at night, we'd be in real trouble. Because of its utility and ubiquity, it becomes the basis for other knowledge. I'll talk about that soon. But spatial knowledge is quite different from geometry or physical measurement. We have systematic distortions that have to do with our perception of space and our actions in it, and they're tightly coupled. So the book goes into spaces of action, brain, spatial abilities, perspective, gesture, language, cognitive tools, creativity, design of the world. And I'll touch on a number of these topics, not all. So what is thinking anyway? I think the dominant view is that thinking is like language. We see this in our own intuitions about thinking, in philosophy, in linguistics, and certainly in psychology. But thought happens in neurons and probably in muscles, not in words. And those words just pop into our head. How does that happen? We have no intuition or insight into that. And that's where the thinking is. So where are the words here? We have people playing rapid basketball or any sport or walking down the street and avoiding collisions. And we do that effortlessly, seamlessly, by reading space, reading other people's bodies. Here it's especially impressive because you have to fake out the opposing team and communicate to your own. And it happens in split seconds, much faster than speech could ever happen. So what is thinking here is an attempt to define it, and I'm certainly open to a discussion. It's representing things and relations in the mind where they can be worked on. So again, the audacious claim is that spatial thinking is the foundation of all thought, not the entire edifice, but the foundation. And I'll bring evidence for that from brain, from gesture, from graphics, and from language. Some of this will be a little superficial, but there is more backing to it. So when thought overwhelms the mind, as it often does, the mind puts thought into the world. And the mind can put thought into the world in graphics, things that we write on a paper, or arrangements in space, in gestures, in words. And I'm going to argue that graphics and gesture communicate more directly than words, which only have, for the most part, symbolic relations and arbitrary relations to what they're representing. Gestures and graphics are more direct. So as I just said, they're a direct form of expressing meaning in contrast to words. So I want to show you some people thinking before I go on. This is an introduction to some of our work on gesture. And we put people alone in a room. These are students, they're good at learning. And we tell them to study descriptions of environments. This is one, it's only a partial description. The descriptions located 4 or 8 landmarks in a complex environment, and they would be tested on it. So this is difficult. So Etna is a charming town nestled in an attractive valley, entered on River Highway. River Highway runs east-west at the southern edge of the town of Etna toward the eastern border. River Highway intersects with Mountain Road and so forth. These were originally developed in collaboration with Holly Taylor, and the gesture work was with Ozzy Jamalian, Valeria Giardino, Melissa Bradley, and later Lu Yang and Lu Yang. So they read these descriptions, they're alone in a room, and I want to show you one person who is studying the description. You can watch her hands. Nobody told her to gesture, nobody mentioned gesture in the instructions. We only said your task is to learn these, you're going to be tested on them. About 75% of people spontaneously made these sorts of gestures. They were models of the environments that they were reading. You see she's making points or circles for places and lines for paths. She's not looking at her hands. When people do this, they perform better on the tests. And when they when we tell them to sit on their hands, they perform worse. So another set of studies we ran, we gave people explanations of mechanical systems. Here again, a written one of a car brake. It's quite complicated. And here is somebody studying that. You can see he makes very big gestures, and he'll make smaller ones too. He repeats the gestures. There is a smaller one as he's reading. That's a kind of rehearsal. Again, he's not looking at his hands, but you can see he's embodying that's not a gesture. He's embodying the situation that he's reading about. And I'm going to give you a third example. I have many, many, many of these. She is reading a schedule. It's a set of events that are happening at the same time in different places. And again, she's going to have to remember them. And she's looking at her hands a bit, but most of the participants, most of the time, are not looking at their hands. And again, when they do this, they remember better. I get the feeling when I'm watching these that the gestures are turning the language into thought. The language is hard, understanding that is hard. They're making models with their hands, and that is somehow turning it into thought. They're spatial motor, they're with their body. And again, if we prevent it, they perform worse. In fact, some of the participants in the cases where we prevented it said, I can't think without my hands. Okay, so gesture models seem to be spatial motor, not visual. So let me go on to brain evidence. It will not come back to gesture, but I'm open to questions on gesture. We've by now run a number of studies showing gesture changes thought in the people who view them, in particular in representing action. It has a huge effect in understanding action, but I can't talk about all of that today, but am open to questions. So actions in the world form the foundation of thought, and the same brain structures that represent places in spatial representations also represent events, people, and ideas in temporal, social, and conceptual spaces. So this is work that won the Nobel Prize for the Mosers and John O'Keefe. First, the place cells, that single cells in hippocampus, the red is firing of neurons in single cells from implants in rat brains. Similar work has been done on humans. So the place cells fire when the rat is in a particular place. So they're encoding places. They aren't arrayed spatially. And in fact, each time the rat encounters a new environment, it sets up a new set of place cells. So they can't quite be a cognitive map. The Mosers, working in O'Keefe's lab as postdocs, found grid cells one synapse away in entorhinal cortex that array the place cells in a grid. So the grid isn't metrically arrayed. It's approximately metrically arrayed, but it apparently has distortions that have to do with reward structures and so forth. So it's already distorted in the way that I'm going to claim that human representations of space are distorted by the actions of the animals. So recent work on humans has shown that place cells code people and events in time and conceptual relations, and that they're arrayed in a conceptual space in grid cells. So that seems like strong evidence that the same brain foundations that represent space also represent concepts and conceptual relations. So the analogy I use is that the hippocampus sets up checkers for ideas, and the checkerboard is relations among ideas. Okay, so networks we have everywhere in street formations, social networks. This is a set of studies we did asking people to array their social networks, and they seem to separate relatives from friends in interesting ways. Phylogenetic tree of life is a network. This is a network at the Museum of Modern Art representing the modern art movements of the 20th century, very familiar poster. This is art, Mark Lombardi. They take up a whole wall in a gallery, and they're following the money. There's social, political, economic relationships, and they're beautiful and they're intriguing. So we have networks everywhere. So, and thinking. So thought comes from actions in the world. Our minds go from thought to thought along relations, just as our feet go from place to place along paths. Those are our networks. And our mind, these are our feet and our hands. Our minds act on ideas, just as our hands act on things. So actions on ideas are the same as actions on objects. We raise ideas, we pull them together, we tear them apart, we turn them upside down, we kick them around. And these, as I have done, are also expressed as gestures that are truncated forms or stylized forms of those actions. And in fact, it's very difficult to think of actions on ideas that aren't actions on objects. So in some sense, these aren't metaphors. That's the way we talk about actions on ideas, as if they were objects that we were manipulating. So paths form spatial schemas for thought. We have dots for places, just as you saw in the first gesture. We have lines that connect the paths, showing the relations between them in space, spatial relations, in social networks, social relations. These form networks. We have boxes that include ideas, contain them, separate them from other things, or our areas for ideas. Then we have the way our thoughts move. They can move in straight lines, along networks, in circles, in spirals, in zigzags. And then we have perspective, another important spatial concept that has consequences for thinking in any domain. I will come back to that. So I'm going to give you a tasting menu, a bit of fleeting through a great deal of our research, not all of it. So I'm neglecting many research partners and areas of research. I won't be able to talk about storytelling. It's another long story. And I'd love to do it another time. So, and I had many wonderful collaborators along the way, and I'm sure I won't remember to mention all of them, but they do appear in publications and in the book. So first, we were interested in the spaces of human action. And we distinguished three spaces that are important to action. We didn't investigate them in this order, but it makes sense to talk about them that way. There's the space of the body and how it acts. There's a space immediately around the body in reach of hand or eye. We can see it by swiveling. Then there's the space, the larger space of exploration, the space of our homes, of our towns, of our workplaces. We can't see them from a single glance, so they need to be put together from many different experiences. And some of the experiences are actual ones. We're in the environment exploring, but some are from maps, some are from descriptions, and so forth. And my main contention is that each of these spaces is distorted or biased by the intertwined perception and action in those spaces. So, and then I will talk about the spaces we create to improve our own cognition and our own social behavior, our own physical behavior. So in maps, sketches, social spaces like classrooms, and urban spaces. Again, I won't be able to go into depth in each of them, but just a glimpse. So first, more on language. We already said that we can hardly talk about thinking without using the language of acting on objects. In addition, we have figurative spaces that we use with complete and instantaneous responding, often again accompanied by gestures that show the actions. So we say someone's out of depth, somebody's opening a new field, somebody's at the top of a class, somebody's feeling up or fell in a depression, we got closer, we fell apart, we're thinking out of the box. So these expressions are in many, many places. Lakoff and Johnson brought together some of them without kind of a theoretical framework, but many of them come from, the ones I've been interested in come from space and action. So then we have spaces for meaning. And again, we have that in language, gestures, and graphics. So proximity in space indicates proximity on any abstract dimension. So we've gone closer. We can say that ideas are far apart, ideas are close together. When we think about space for meaning, the vertical is loaded, good things go up. And it's probably because as we get older, we get taller, and fighting gravity takes resources, it takes money, it takes health, and size, so that upwards is loaded in just about in every language that I've encountered or my students have represented. So again, somebody is on the top of a heat or has fallen into a depression. The horizontal is more or less neutral. There's nothing in the environment that biases horizontal, and what's horizontal keeps changing with our viewpoint. But there are cultural conventions that seem to have strong effects on the meaning of horizontal. And one of them is reading and writing order, where if you read Western languages, the beginning is left to right, and then there are other languages like Arabic, Hebrew, and older versions of Chinese and Japanese that go right to left. And there's a whole cottage industry of people showing effects of these cultural factors on perception of beginning to end, and it increases. And we contributed to that many, many years ago, experiments that we did on Hebrew speakers, Arabic speakers, and English speakers. So I won't have time to go into that. Then we have imagined spaces. We'll talk a bit about that. There's nothing there because they're in the head. So let me say just highlights of these three spaces: the space of the body around the body, space of exploration, and again, our actions shape our representations. These are bodies as drawn by children all over the world. The hands, the head, the feet, the legs and the arms are well represented. The other body parts aren't. It turns out that these are body parts just about universally named across languages. So they seem to be conceptually important body parts, and they're functionally important body parts. They have a bigger real estate in sensory motor cortex. This is what we would look like if we were proportioned the way we are on sensory motor cortex. Julie Morrison and I did a number of studies looking at body part verification tasks, where we chose the most highly named body parts, and we did a variety of comparisons, body, name, and so forth. On the whole, we found that the more important, functionally important parts like head and chest, this was ratings of our participants, hand and foot, were verified faster than the large parts, arm, leg, and back. So this doesn't go with an imagery theory of verification where the large parts would be verified faster. It goes with a conceptual functional view of the body parts. With Franklin and Bryant and a couple of others, we looked at the space immediately around the body, and we found again that the functions of the body, the actions of the body, determine the accessibility of objects that we've located in imagination, above the head, below the feet, in front, in back, to the left and to the right. And because the head, foot, and front back axes are asymmetric, they are more accessible. And because for the canonical upright person, gravity is aligned with head, feet, for an upright person, objects that are at head and feet are located faster than objects that are front and back. That's second, and left and right is slowest, and in fact confused by many people and not labeled in some languages. So again, our actions in the world, the functions of our body in the world are affecting the accessibility of the things around us. So finally, the space of exploration, too large to see. Here there are a number of distortions, and some of this work was ours, some was other people's, and they're very different heuristics or biases that are hard to reconcile. The idea isn't that we have maps in our head that are more or less veridical, and when we're asked to make a judgment about distance or direction, we call up the map, we look at it and make a judgment. We don't have maps in our head. We have partial representations that we pull together as needed. And of course, this is true of any judgment. We pull together the information we think might be relevant, try to integrate it, and then make our best judgment. But it leads to a number of distortions. So this is work of Stevens and Coop. They asked students sitting in San Diego, what's the direction from San Diego to Reno? The map on the right on my screen is the veridical map, and you can see that Reno is actually west of San Diego, but most people thought it was east of San Diego because you can't remember the directions of every city to every other city. So you do it by hierarchical inference. You know on the whole that California is west of Nevada, so you assume that all the cities in California are west of the cities in Nevada, as if this were your map. Not quite. It's not a good representation. But in any case, people do use that hierarchical organization to infer directions of cities and not some veridical mental map that they have in their heads. And this study has been replicated in many, many different places with reaction time as well as distance estimation. So it's a robust effect. It happens also with conceptual hierarchies. So Janides and Hurdle did a study in Ann Arbor asking distances between university buildings and city buildings. And again, the university buildings were seen as closer to each other and the city buildings as closer to each other, even when that defied actual geography. So it holds for conceptual relations, and it holds for social judgments. All of these factors that are spatial work on conceptual judgments and work on social judgments, which again is evidence that spatial thinking is foundational in conceptual thinking and social thinking. So this is a Steinberg cartoon, but work of Holyoake and Ma. Steinberg is looking out of his window toward 10th Avenue, the Hudson River, Europe, and you see the distant landmarks get squished, and the close ones are larger. And Holyoake and Ma showed that for judgments of cities across the US. Again, a robust finding. Sadala and McNamara showed this sort of distortion, that people think that ordinary buildings like Jacques' house are closer to a landmark like the Eiffel Tower than the Eiffel Tower to Jacques' house. And this is an asymmetry of distance that Euclidean space won't tolerate. So, but nevertheless, people make this judgment quite reliably. Many, many years ago, Eleanor Ross showed that people think that magenta is closer to red than red to magenta. Red is a prototype and draws the non-prototype colors closer to it, just like the Eiffel Tower defines a landmark and draws buildings within it a certain radius is closer. And similarly, my husband years ago showed that people think that North Korea is more similar to the PRC than the PRC to North Korea. So again, these spatial effects hold for conceptual ones. So we did work on alignment, a kind of perceptual grouping that people group North America with Europe and South America with Africa. And so they prefer this bottom map to the top map, which is the correct one. In the bottom map, we've lined up Europe with the United States and a little bit lined up Africa with South America. People align in their minds and they prefer that map to a more veridical one. Similar thing happens in the Bay Area. People tend to upright it. So people sitting in Stanford think that Berkeley is west of Stanford when it turns out to be east of Stanford, and because the Bay Area is at an angle, but people conceptually upright it. So putting these things together, cognitive maps are impossible figures. We can't reconcile all those different distortions together, although bringing more of them together does tend to correct the judgments, as it does for any kind of judgment. So we argue that cognitive maps are impossible figures and that they're more like collages. They're multimodal and incoherent and perhaps more beautiful. And again, we've shown that there are parallel errors in conceptual and social relations with all of these effects that are spatial. Okay, another important spatial concept is perspective. And in real space, we can take overview perspectives. This is a map of Stanford campus, or we can take route perspectives as if we were walking through it. When we take a route perspective, and in a description, we describe landmarks to the right and to the left as we move through the environment from our own perspective. When we describe space from above, we describe landmarks in terms of each other and in terms of left or in terms of north, south, east, or west. So these are quite different. And Taylor and I ran a number of studies, either having people experience environments or experience them from maps that was more typical, and then describe them. And what we found was contrary to what the linguists and the philosophers say about coherence of perspective, people more often than not mix perspectives. So their descriptions were partly route, partly survey. We could predict a bit when they would use one and when they would use another. So it didn't depend on the person, it depended on the environment. People switched, and people have little difficulty understanding the mixed environments eventually when they learn them. And Taylor and I were able to show that the representations that people end up with from descriptions are essentially perspective-free when they're learned well, and they allow taking any perspective on it, either a route one or a survey one. And think about an environment that you know well, and you're probably able to give somebody directions from a route perspective or describe where the landmarks are relative to each other from a survey perspective. So there's perspective from above or below. There's also your perspective or my perspective. And this, of course, is important in social situations, but it's important cognitively as well. Bridget Martin Hart and I ran a number of studies. This is her husband, Patrick. And we showed people this photograph. And we said, with respect to the bottle, where did Patrick put the book? And we were talking to subjects who shared our perspective. So from our own perspective, the book is on the right. From Patrick's perspective, the book is on the left. We already said left and right are hard for people, and reversing them is even harder. Nevertheless, when we asked people, where did Patrick put the book? More participants took Patrick's perspective than their own, which was shared with their interlocutor. So this study too has been replicated many, many times, and it's even faster for people to take the other perspective than their own in this sort of situation. So taking our own perspective isn't necessarily primary. Primary can be the other's perspective. Why might that be? We want to understand Patrick's action. It might have implications for our own action. He might give us the book, he might throw it at us. So we have to prepare our own action depending on Patrick's action. And so taking his perspective will allow us to understand his action better than taking our own perspective. And again, this sort of thing has been shown in a number of subsequent experiments. So perspective taking doesn't just underlie action preparation. It underlies empathy. It underlies problem solving. We've been able to show that taking another perspective helps people solve problems. It underlies prediction. Phil Tetlock has shown that people who take other people's perspectives and challenge their own are better predictors of world events than people who don't do it. It underlies creativity. We've shown that people who are encouraged to take other perspectives come up with far more creative solutions than people who just let their minds wander, for example. That's been a popular view in the press. But it turns out that perspective taking and taking alternative perspectives is far better than mind wandering in coming up with creative solutions. This is work with Juliet Zhao. So we've just put the world into the mind. Now I want to show you some of our work on putting the mind into the world. We already said that that's something that human beings do, and nobody has seen a gorilla make a map for a conspecific or even a human, or draw a map in the sand. So this seems to be a uniquely human enterprise. Now, animals mark their territory, but and that has some cognitive social effects, but they haven't been seen deliberately to make external representations for their own cognition or the cognition of others. With all of these things, there's bound to be an evolution. But we're somehow doing it better, and it's made a huge difference in the world we live in. Think of going back, as I did 2 weeks ago, to the savannah, watching people who are hunter-gatherers, where the environment is all created by nature. And then think of us, where almost everything we encountered, we designed. And we designed for reasons. I'll come back to that in a minute. So putting our minds into the world. Putting our minds into the world is done in part with external representations, in part with gesture, certainly with words. And these are cognitive tools that we can work on. They expand the mind beyond our working memory. They facilitate information processing by offloading information processing to the world. Imagine multiplying 2 3-digit numbers, taking square roots without pencil and paper or a computer. We don't know how to do it by pencil and paper anymore. They convey information to others and they last. So they were still understanding information put out into the world 40,000 years ago, 60,000 years ago. They promote inferences because stuff is out there, freeing your mind to make inferences from it. In that way, they enable new ideas. They facilitate collaboration. I'll talk a bit about each of these. So maps go way back in time. This is the former oldest map. It's after writing. You can see writing on it. It also shows both an overview and a frontal view of landmarks. You see paths and landmarks. It's schematic, full of distortions. So it's showing all the qualities back then that I ascribe to the mind now. This is the currently oldest map. It was found in a cave in Spain. It's about 1 inch by 2 inches, a tiny stone. It contains carvings of the world outside the cave. And it's again schematic. It's partly realistic of the mountains and the terrain. There are horned creatures there and so forth. So it's showing more than one point of view. And imagine the thrill of the archaeologist who walked in the cave and picked up what he thought was a stone and found a map. It's the thrill of a lifetime. So these are other kinds of maps. These were used by coastal Eskimos in Greenland. They're tiny, they fit in a glove, it's cold. They have the indentations of the coast carved in the mitten. They go both sides, so they're compact. If they fall in the water, they float. More seafaring maps. These are South Sea Islander maps. The bamboo strips are the ocean currents. You can think of them as the highways of the ocean. The shells are the islands. The islands can be thousands of miles apart. You can't see one from another. And they were used by navigators in conjunction with stars, and at least some of them got back home. So this is a valley in Italy, the Bellino Valley, filled with petroglyphs. This is a drawing of a petroglyph of maps from about 4,000 years ago. And again, you see both perspectives. A map made by a hand of North Coast Indians showing the major settlements even before the beginning of the United States. This I took last week in Istanbul. It's in Topkapi Palace. It was used to show people who couldn't read and were newcomers to the palace, in many cases eunuchs that were captured in Africa. And they were brought to the palace and they needed to know the governance structure of the Ottoman Empire. So at the top is Topkapi Palace, is the Ottoman Empire. These three little crowns in the middle are the three caliphates under the Sultan, and below that are the city-states around them, and below that are the Bedouin tribes, and below that are the nomadic tribes. So it's a hierarchy, and it isn't capturing the geography exactly. On the contrary, it's capturing the hierarchy of governance that also, in some sense, maps onto the geography. So this, I'm not sure when the tile was made, but the palace, so I'm estimating around the 18th century, but I was fascinated to learn about that tile. Another map, this is a New Yorker map of New York. So now we have space in maps. Those are shown in ancient times. We also have objects of various sort, especially animals, people hunting and so forth. And this is from Lascaux, going back 15,000, well, going back 12,000 to 17,000 BC. This is from a valley in Utah called Newspaper Rock. and it was used by Native American dwellers there. There are hundreds of these petroglyphs all over, and this one's showing a hunt. So you see people with bows and arrows, the animals that they're hunting. These you see all over the world. They're events that are important in people's lives. This is a very special event. On the left is the stone that it was carved into in Kashmir. On the right is a drawing of the petroglyph. It was made by, you can date it by around 4,000 years BCE, so 6,000 years ago. And an Indian astronomer dated it. I mean, why are there two suns? An Indian astronomer dated it to a supernova. So that was an event so powerful that somebody carved it into stone for all times to remember. And it was only 6,000 years plus later that the Indian astronomer understood what the people at the time were representing, a major event. So we have more articulated events. This is making bread in Egypt in the tomb of Mena, probably again going back 4,000 years, Trajan's column, documenting Trajan's conquest. It's so far up you can't see it, one wonders, but you know, towers indicate strength and rulers have to show strength. Bayeux tapestry, again, events in time. This is from China. It's showing the travels of an emperor to that shrine on the pagoda on top of the mountain to pray. So we have events in time. We also have calendars. And again, they go way back. You have a Mayan calendar, a Chinese calendar, both of them representing cyclical information. In other work, we found that people find difficulties representing cyclical events as circles, despite the similar origins of the words. They prefer to represent them in lines because time always goes forward. It doesn't go back on itself, much as we sometimes wish it would. So there are other calendars that are more like the calendars on our desktops that are tables, not circles, again, going way back in time. We have number, not number as we use it in school, but tallies. And tallies, again, go way back. These tallies are on stones or bones. You can find them going back 70, maybe 100,000 years. What they were counting, we can't know, but they seem to be tallies where one line equals one mark. It's not numbers. It took centuries to develop numbers. So another tally on a monkey bone, and this is going back 22,000 years in the Congo. You can see it in Brussels. Another method of counting, we only use our 10 fingers. Other cultures were cleverer and used many more parts of their body so they could get to higher numbers. And here we're using the body to keep track of numbers. And of course, we use the body, hands, feet, as measurement, going way back in Japan. Tatami mats are a common unit of measure because they're standardized. And then we get the abacus, which has a bit of a one-to-one relationship, but it's far more sophisticated than that. So ancient graphics all over the world, and I've only given you the tip of the iceberg. I have a vast collection. They represent people, animals, things. They represent place and space. They represent time and events in time. They represent rudimentary forms of number. And modern graphics are the same. You pick up any issue of USA Today, any technical journal, and you'll find similar sorts of things, representing things in the world, representing places and spaces, representing time and events, representing number. So, and in many of these cases, we have dedicated spots in the brain for keeping track or for recognizing them. Modern graphics probably began with Diderot And although there are some examples, scattered examples throughout the Middle Ages, but they're very scattered. And one of the reasons might have been pencil and paper. It's hard to know. Another might have been scientific. In any case, there were spatial uses of language for abstract concepts going way back, but not external representations. Diderot has some 2,000 plates like this. It was done in France over a long period of time, some of which Diderot was jailed because of his revolutionary sentiments. The top shows a scene. This would have been familiar to 18th century viewers. They would have seen a scene of a factory. It's disturbing to us because there are children. The bottom part is what we might call a catalog. It's showing the tools used in pin making, the top part, and it's lining them up in rows and columns. The sizes aren't proportional to the sizes that they actually are. They're made so you can see them. The lighting at the top is by the sunlight coming in from the windows. The lighting at the bottom of the different implements is to highlight the 3D structure. So these are some of the qualities of a diagram already invented by Diderot. It turns out Da Vinci invented many more, but they were hidden. That's a whole nother talk on Da Vinci's diagrams. But Diderot was far more public and accessible. You can find them online. They're really quite beautiful. Imagine making 2,000 plates like this, etching every one. It was a momentous enterprise. At the beginning of the book is a conceptual hierarchy, conceptual network. I don't have an image of that, sorry. Shortly thereafter, charts and graphs appeared both in England and in Switzerland. And they look surprisingly modern. We have balance of payments in favor of England, against England, and it's showing quantities over time, which is still the most common graphic, both in scientific journals and in everyday newspapers. This is probably the most poignant graphic of all times. It was done by Minard, a French professor of mines and fields, and he was visualizing Napoleon's unsuccessful campaign against Moscow. So this thick line are the troops that left France, that was the border, and progressed to Moscow. You see a lot of the troops were already lost before they got to Moscow. So it's using space geographically and also to represent the size of the troops. The black is the retreat. Look how many got back. Every president or premier of every state needs this in front of his or her eyes, and it's more commonly his, before they go to war. It's not the generals that make war. They, on the whole, want to preserve the lives of their soldiers. It's the world leaders. And we have a terrible example in the background. This graphic also uses space in another way to indicate temperature, which again was a factor in the retreat. So we have space used in many different ways. Because of the artful design, it's easy to understand. This is a natural map. It's Manhattan and some of the surrounding areas. It's simply created by light at night. These are the areas that are lit up. The most lit up area in Manhattan is Times Square, which is bright as daylight. Okay, so creating effective graphics. This was a long project with Julie Heiser, Manish Agrawala, Pat Hanrahan, and a number of others. So it was a collaboration with computer science, and we were interested in creating effective graphics. Many of you probably have instructions for putting together things where they're incredibly complicated. You can't follow them and you end up with extra parts. So we wanted to create good ones, and we wanted to develop cognitive design principles. We did that by having people put together a TV card and then produce diagrams for putting together a TV card or visual instructions. We took other people who gave their preferences for different kinds of visualizations or visual instructions. And then finally, we did performance. We embedded those cognitive design principles into an algorithm that the computer scientists used to take apart objects and then create instructions using the design principles that would be good instructions. So this is, our high spatials gave us good explanations. They were step by step. They showed perspective, and they showed the perspective of action where the actions have to be taken, and they added guidelines and dotted lines to show you the action. They also had a narrative structure. Many began with a part menu. This one doesn't. Many ended with this sort of sparkly line. We did it with gestures. We did it in a number of different ways, and with gestures, people present the TV card. So it has a narrative structure, a beginning, a part menu, like a recipe, then step by step, and then an ending. So these were the qualities, the design principles we brought into the computer algorithm. This is an example of the computer algorithm. It's again step by step, using guidelines and arrows and showing the perspective of action. And when we held our breath and ran a test of new participants and putting together the TV card, either with the algorithmic instructions or the ones that came in the box, we won. And our people using our instructions assembled faster and with fewer errors. So this is a whole program, the 3 Ps of using production, performance, and preference and performance for creating effective effective graphics. And a number of other people have been using this program successfully. Okay, mixing time and space. We did some work on comics. This was with John Bresman, and comics are so inventive in storytelling. They mix time and space. This is a common kind of cover or a mid-section panel, and it's showing you the entire space with the action imposed in the panels on it. So you get an overview of the space and understand that, and also understand the details. This is from Larry Gonick. He has a number of wonderful comic guides to chemistry, algebra, calculus, statistics, sex, environment. They're absolutely masterful, and he uses visualization. He builds up diagrams from the real here to something diagrammatic, and it helps you understand the abstract visualization by visualizing the actual process. He has many, many inventive devices, but again, that's another talk. We have visualizations here in Harold and the Purple Crayon, lovingly translated into many languages, and Harold draws his world as he's describing it, and at some point he meets an alligator or a lion or something, and his hand just starts to tremble, and he finds himself in a lake and in the water because he's made waves unintentionally, and then he has to draw a boat to get himself up. So this is something a 3-year-old or a 4-year-old can understand, that Harold's creating the world and drawing it as he's experiencing it. More Steinberg, I have probably 1,000 of his. So meaningful marks, how are graphics created? They're made up, this is a recipe, they're made up of icons for things, and they can be metaphoric icons like scales of justice or White House, but there are things that are more or less depictions representing themselves or something like it. But then we have meaningful marks like points, lines, arrows, and containers, and each of these have meanings. We've done a series of experiments where we've we've presented people with visualizations, asked them to interpret them, and then given interpretations to other people and asked them to produce visualizations. And when we get the same visualizations back, we think we've got something that's understandable, both in production and in comprehension. So we've done it with sketch maps and descriptions of environments, and they're mostly lines and paths. Work with Paul Lee. We've done it with bar graphs and line graphs with Jeff Zaks. So bars contain and separate, lines connect. They say there's a relationship between A and B, and just A and B have different values on it. This one says the A's and B's are different. And we get discrete comparisons when we give people bar graphs, and we get trends when we give people lines, and vice versa. If we describe trends, people give us lines. If we describe discrete comparisons, people give us bars. And this is often in the face of real world relations of the variables. And it's not what statisticians necessarily recommend. It's what the visual objects, lines or bars, are communicating. Arrows, this is again with Julie Heiser, and we found that when we gave people structural descriptions and asked them to produce diagrams of a car brake, they gave us labeled diagrams. When we gave them causal descriptions, they didn't label the parts, although they were there, but they used arrows. And again, we found vice versa. When we give them diagrams with arrows, they give us step-by-step from beginning to end descriptive interpretations. When we give them structural diagrams, they give us a description of the structure. So arrows change the meaning drastically of a diagram. It's again a longer story. So these are clear diagrams. There are times we want messy ones. And we've studied architects, and they make messy sketches early on. And when they re-examine their sketches, they see new things in them, things they didn't intend. And this is a productive cycle. So experienced architects will see conceptual relations, like the traffic will not flow well, or the light will fall badly in the winter. Unexperienced architects, and they're still trained, will see patterns like a triangle here, but they won't see the conceptual. Now, this has been shown previously with chess diagrams and music. So in order to interpret the diagrams, you either need expertise or talent, and in order to make these more abstract conceptual inferences from the diagrams. Andrea Kantorowicz, working with me, found similar things with artists for whom drawing is their major occupation. They're earning their living by it. She studied a dozen of them as they were drawing. She asked them at first, tell me what you're thinking. And they said, I can't talk when I'm thinking. It's a conversation between the eye and the hand and the page. It's highly intelligent, just like the basketball game, but it isn't in words, and words get in the way. There's more on that too. Artists say the ideas emerge from the page as they see them. They say they deliberately get themselves in trouble. Her dissertation is a goldmine of the creative uses of sketches in thinking. So creating visual explanations, Eliza Bobook and I asked, would that be a good way to learn, in this case, chemical bonding? So she taught chemical bonding over a period of many days to junior high students. Then she divided the class in half, tested them, and each group tested the same. Then half of them made visual explanations of chemical bonding, half made verbal ones, and then she retested. They didn't have new learning. Both groups improved without new learning, just from making an explanation, but those who made visual explanations improved far more. Here are some of their visual explanations. They came from their own minds. They weren't what they saw. We have sharks grabbing electrons. We have little people giving electrons. And she looked at the information contained in the diagrams and in the verbal explanations, one word after another, and found actually there was far more information that was crucial to understanding in the visual explanations than in the verbal. And we think this technique of making visual explanations can be used objectively and for all kinds of material, not just science. The visual explanations give you a check for completeness. Is everything I need there? They give you a check for coherence. Does it make sense? They give you a platform for inference so you can add new things. You see what's there, and you can add new things. And most important, they're a direct mapping of meaning, just as the gestures that you saw initially were. Okay, inference. This is going back to the early 20th century. There was a cholera epidemic in England. There was no theory of germs, of how disease was transmitted. Snow asked, he was in charge of the city's health, asked for a diagram of a map with the cases of cholera. Here, you can see them here, each is a dot. They clustered around the Broad Street pump. Without knowing that cholera went through water, he had the handle of the pump removed and the epidemic abated. So using these sorts of diagrams to trace disease is still done today, or trace pollen, or trace whatever migrations. Maps are a huge tool for inference. This is World War II. There were bombers being sent from the UK. Some of them were coming back, some of them weren't. There was a small amount of money to reinforce them. Wald had a diagram made where a black mark was put in this blank diagram for every plane that came back. Eventually, it looked like this. So where do you reinforce the bombers? In these two places, because those are the ones that didn't return if they were hit there. Now it happens to be the pilot and the co-pilot. But that was how the decision was made, the inference made. Archaeologists make inferences all the time from the spatial array of the ruins they're investigating, where there are large buildings and small buildings. It indicates a hierarchical structure and so forth. The way space is arrayed and size is used and distance is used tells us a huge amount about the social and governmental organization of the society. Topkapi is filled with that, another story. This isn't going to move for you, sorry, but we've done a number of studies, again, Julie Heiser, showing that having joint graphics that you can point on aids collaboration. It leads to better outcomes. It leads to more satisfaction from the collaboration. It leads to more interchanges, so a better collaboration. And this is something Zoom doesn't have as easily, a joint space that we can all rearrange and see. This is the world as it was given to us, not the asphalt, but the scattering of leaves. This is the world as we design. Even more, we put our mind into space. We line up our books by size or by category or by time when they were printed. Our supermarket shelves are categorized. Our dishes are categorized and subcategorized into hierarchies. So all of these are ways we organize the world in our minds. We put them out into the world. That means that I can understand a supermarket wherever I go, and I can know if I go to the cashier and put the purchases on the counter, the cashier will understand I want to purchase. And so that I can communicate by the way I use space. We also put themes in the world, not just categories. Our houses collect things from many different categories, all the things for sleeping in a bedroom, all the things for preparing food in a kitchen, all the things for conversation in a living room. So things for different, from different categories organized by a common function or a common theme. So that's again, ways we organize our mind and organize the spaces around us. We have one-to-one correspondences, repetition cycles in our place settings, in our windows and apartments, in 3D, in our buildings in the world. And all of this, in contrast to the savannah I was seeing 2 weeks ago, communicate a huge amount about the world and what's in it and how I can navigate it. And we use those organizations, the categories and orders and so forth, to create visualizations which intentionally communicate. So a periodic table, railroad schedules. This is the likelihood of a computer issue being solved by reconfiguring something, reimagining antivirus software, uninstalling other jargon, or turning it on and off. So jokes too, we use, this is how long it took me to draw and color each of the bars. So we use these intentionally to these organizations of our mind that we put in the world. We then use them intentionally to create effective graphics to communicate abstract ideas. So I brought this together in a concept that I call Spraction. Actions is a contraction, an ugly word because Latinate words are ugly. Its actions in space create abstractions. So the actions in space on objects get schematized into gestures, which are actions on ideas. And the abstractions of the world, the organizations in the world that we saw, categories and hierarchies and orders and themes, get put into diagrams that deliberately communicate those ideas. And so that's Spraction, but we go one step further. We don't just design the world, we've diagrammed it. This is an airport from above. It tells where the airplanes can go, where the service cars can go, where the buses can go, and it directs every vehicle's behavior on the ground, how fast it can go, where it can turn. And we have the same thing in the spaces that we navigate, where bikes can go, where buses can go, where they can stop, where pedestrians can go. So these diagrams enable movement and constrain movement, but our world is now diagrammed. So thank you for your patience, and I'm open for questions. These are some of the granting agencies pointed to by one of my granddaughters. So I'm open to questions.
Great. Thank you, Barbara, for this really interesting talk showing how closely thought and action are aligned. And there has been a lot of interest and already some questions posted in the Q&A. And so I'll guide you through those so you don't have to worry. You can focus on answering the questions.
Should I stop screen share?
It's up to you. If you feel like you might want to go back to some of your slides, you can leave it up. But...
And I have, 300 more that I didn't use. Okay.
So maybe some of them you'll use now. We'll see. Okay. So the first question is from Katharina Kühne. Do you know if smaller distances are estimated more accurately than larger ones?
You mean a Weber-Fechner sort of thing? I haven't looked at that directly, but I would imagine. But they would still be subject to certain distortions. I didn't talk about those, but a number of people have looked at how this is small walking distances, how the number of landmarks or turns along a route lengthen the perception of the route, so that the more turns you make, the longer you think the route is, or the more landmarks are there. And that might be using the amount of information expands the distance. So even small ones can be distorted, not just by a kind of Weber-Fechner sort of idea, but also by the way we experience it. A lot of people comment that the route home seems shorter, And that again is probably because we know how to get home. There's less information that we need to process. So there are fewer segments to going home than going forth. And the number of segments, and the segments won't be just distance, there'll be information, will distort it.
Very interesting. Thank you.
I guess another phenomenon that people often comment on is that they go from A to B one way and come back from B to A the other way. And I believe, and I think there's work on it, that when you set out, you don't want to turn against where you're going. You want to turn toward it. And sometimes that isn't the best route. And then going toward from A might be quite different than going toward from B. So that might be one of the reasons why people pick different routes. But I believe somebody's looked at that systematically, and that's the more or less the reason, but I can't be sure.
Okay, thank you. Then the next question is by Erica Fulton, who's currently teaching a graduate cognitive psychology course, and so was wondering about the connection of your work to working memory models. So she can't help but wonder how Baddeley's working memory model might explain your assertion that thought language as phonological loop has its foundation in spatial relations and actions, so in the visual spatial sketchpad, or whether his model might be revised in light of your argument and supporting evidence. So might you be able to comment on your argument vis-a-vis working memory models?
So I'm not understanding the question. Is the problem with the model of working memory, or is it about working memory? I'm not understanding the question.
As I understand the question, the question is whether your work is a problem to the working memory model. But let's see if Erica maybe wants to chime in on this. I don't know if she is able to.
Yeah, I guess I'm just thinking about representation of language being distinct in some way from representation of space in Baddeley's working memory model. And if your assertion, I mean, it doesn't have to, but if your assertion would contradict that in any way, or I guess, or maybe the flow of information between the quote unquote slave systems and episodic buffer, might that be revised given your argument? I don't know if I'm making more sense.
And I'm not going to be completely clear on it either, but he does contrast a visual spatial, and I think later contrasted visual from spatial working memory. I'm not completely up to date on the work on working memory from a verbal. So, and this would be some of what I'm talking about. The initial experiments that I showed you on gesture would be taking language and turning it into a visual spatial or spatial representation. That would have to happen in working memory. And I think you saw, especially the guy looking at the car brake, but also the woman doing the environment, that they were doing it in chunks. So they were building up chunks, and you could think of that as a kind of unitization, which does end up taking less space in working memory when we do FBI, TWA instead of random letters. So it would be a way of unitizing, breaking things into chunks, unitizing them. And they are refreshing, they're reading again and chunking again. So they're doing some kind of chunking, but also translation. So in contrast to kind of the early Sperling work where you translated the visual into auditory, or that was the claim, here you're really translating the verbal into something spatial motor, but doing it in chunks. So it's not only dependent on working memory, right? There's no way that somebody could read those descriptions. I only showed you part of them in one working memory unit. It's done in chunks over time, the way you read a textbook or a novel, and you're constructing mental models as you go. It doesn't fit as neatly into the paradigm that they use, where they give small amounts of information to study working memory. Here, it's information that goes far beyond the working memory. But again, what seems to be required is turning the language into a spatial motor model to make it coherent. So it's more akin to Johnson Laird's sort of work on spatial mental models. Right. I hope that helps a bit.
Yes, thank you very much.
She posted thank you in the chat. So thank you so much. The next question is by Marilla, and I think it's similar about expressing space in language. So earlier in your talk, you had those examples of figurative spaces. And so she was wondering whether such expressions are found in all or at least most languages and cultures, including non-Western languages and cultures.
So I think probably one of the earliest uses of language was to describe space, was to tell each other where the dangers were and where the food was, and so on. That's my guess. Obviously, we can't go back to that. Many other languages have been studied, and there's an interesting phenomenon that Steve Levinson's group at Nijmegen, no longer there, studied about spatial language in a number of cultures. So they found cultures, Tamil in India, rural Tamil, not urban Tamil, rural Tamil, Celtal in the highlands of Mexico, and Gubiamatur, a language used in the outback of Australia. And none of these languages, according to Levinson's research, uses left and right. They only use some facsimile of cardinal directions. Now, the cardinal directions can be uphill, downhill. These are people that live in the same environment forever, or for the most part. So they're using environmental features to locate objects in space, and they're not using left and right. And in fact, if you give them a drawing of a tree and a man here or a man here, and ask them, are they the same? They'll say yes. So they're not distinguishing left of the tree, right of the tree. What they're thinking apparently is next to the tree, and not some direction from the tree. So that's surprising to most of us who use left and right. And it turns out that many of these, that in some cases, these people are better oriented in space, because in order to talk, they have to be oriented in space in order to describe things. They can't say left or right. They have to say something's uphill or downhill. So this was surprising, and he did a number of cognitive tasks that again showed that people speaking these languages, or I can't remember which, he didn't look at all of them, are, when they see an array of animals in front of them, are using the cardinal directions or the facsimile of cardinal directions rather than their own body, whereas Dutch participants are using their own body. So he argues a bit that we're deficient because we have left and right and we're not keeping track of the world, and that these people are keeping track of the world. So as with many things, it's not quite so simple. As I already said, when Westerners talk, they, and not just Westerners, they mix perspectives. We're not using a pure perspective. We often mix north, south, east, west with left and right, and we do it without signaling mid-sentence, and we understand those sentences. So we don't use a consistent perspective when we have many of them to use. And then it turns out, I asked someone who was doing research on Tamil, I said, okay, so people don't use left and right. Left and right is hard. What about front and back? won't they say your plate is in front of you or your chair is behind you? And he said, he thought for a minute, going back to Tamil, and said yes. So that again, the reference systems aren't pure. They're going to use front and back because front and back are easy to distinguish, but they're not going to use left and right because left and right are very hard to distinguish. So, and then it turns out that when Tamil kids live in cities and go to schools, left and right enters their vocabulary. So it's very interesting and eye-opening to look at different cultures. I mean, we did that with organizing increases from left to right or right to left, and found Arabic speakers want increases to go from right to left, and Westerners left to right. Again, it's more complicated. And number turns out to be especially complicated. So because there are conflicting reference systems. So yes, there are going to be some cultural differences, so far shown to be language. So Tzeltal is a Mayan language, but a neighboring village, a stone's throw away, well, not a stone's throw, but an hour walk away, does have left and right in its language. So it's not there, it's not cultural, it's similar cultures, different languages. So there are going to be differences that are interesting. Laura Boroditsky and other people have looked at up-down as a way that Mandarin Chinese uses. They say calendar events are up from or down from, as well as before and after. It's used in Mandarin. I don't know how common it is, but American users can learn it in 10 minutes, and our calendars go that way. Earlier dates are at the top and later dates are at the bottom. So we're already using that mapping, that vertical mapping. We don't use diagonals. And we use vertical and horizontal, and as I said, the vertical is on the whole loaded with qualitative, all good things go up. The horizontal is more neutral. So time in general goes horizontally, but in calendars it goes vertically, and in Mandarin Chinese. So that's an area open, and there are so many interesting peculiarities. I shouldn't call them peculiarities, interesting, fascinating differences between languages in how they talk about space and time and causality. And many people, thank goodness, are studying that now before these languages disappear.
Yeah, very, very interesting. Thank you. Next, I'll ask someone to join us in expanding on the question. So Ruth Cordray, you should have speaking rights now.
Hi, thank you so much for talking today. It's really fascinating. My question goes back to the beginning of your talk when you were talking about the gestures in the describing places and then how the mechanical systems worked. And I hope I got this right. You described those as preceding thought and then went on to describe maps as succeeding the thought. And I'm wondering if the gesture, if you ever thought of the gesture as being sort of making an invisible map, and if what would have happened if the participants had like paper and pencil there, would they have chosen to draw the map or still gesture?
So those are interesting questions that we have investigated. So first of all, yes, I think there are huge numbers of parallels between graphics, anything we put on a page or a computer screen, or an arrangement in our house, the things we need to take to work by the door. Any of those representations in the world, there are a great deal of similarities to gestures, and they are spatial arrays using space meaningfully, using dots and lines and icons and boxes. to convey conceptual or spatial concepts. So yes, there are strong similarities between graphics and gestures in the way they express meaning directly. Gestures disappear. On the other hand, they are especially good at conveying action. I alluded to studies we've done where we've used gesture to change other people's thought, and we've done that about space, about time, about other concepts, but especially about mechanical systems. And their gestures that showed action that I use to explain how a car motor works to you, give you, make you internalize action to a much greater extent than words. And our tests were just on the words, but people did better on the tests, even though the language was sufficient when they saw action gestures. It's a longer study. We also did visual explanations and videoed explanations. It's work with Sukmin Khan, and it's published. So gestures have an advantage for conveying action, and graphics have or diagrams, charts, whatever, have an advantage of being permanent. So there's a trade-off there, and when used together, as our collaborators on finding a route and a map did, they're especially effective because you can use the gestures to animate the diagrams, and they become especially effective. And in those collaborations, people don't look at each other's faces. They look at the gestures on the diagram. So yes, there are really interesting parallels. They're both graphics and gesture are conveying meaning directly. You asked about before or after. When most people who study gestures do it in the context of speech. And there, interestingly, the gestures precede the words. And the gestures are probably helping the speaker think, but the gestures, because they're communicating directly, come earlier, they're faster, they're more direct than the words. And you can use gestures to set up whole schemas. I can say on the one hand, on the other hand, and then I use a set of arguments and point to those places for each of those arguments. So I've set up a diagram in space using gestures, and I can add to that as I speak. So, and it's hard to do that in speech. I can't say, look, I'm setting up a diagram. This side represents this, and this side represents this, and so forth. It's just very simple and straightforward to do it on the one hand, on the other hand, and continue there. So I hope that helps answer some of your good questions. All the questions are great.
Thank you. So I think we already touched on this a little bit. There's two questions in the chat kind of asking to what all this generalizes. So one is whether your theories and studies on diagrams are also suitable to the virtual world. Is virtual world also diagram? And I think you just touched a little on this.
Yeah, so you know, the virtual world means so many different things to so many different people, and there's always been in computer graphics a huge emphasis on realism, as though making things more real somehow communicates better. And I think I didn't show you this, but an aerial photograph makes a terrible map. It's cluttered with all sorts of information you don't need. And the information you need, like the London tube map, is there, and only that information, and it's legible. You can access it quickly, whereas you're looking at an aerial photograph, you can't even see the roads clearly. So in many cases, realism is the wrong answer. And certainly for visual explanations of history, of chemical bonding, of any of those things, being realistic is not going to be helpful. When we describe those things, we're highly abstract, and often verbal descriptions are a good clue to what we need to understand. So virtual world, it depends on what the virtual world is actually representing and what the purpose of it is. If you want to immerse people into action, or immerse people into empathy, then the high realism, seeing somebody's pain, a refugee's pain, a war battle, that's going to be more effective emotionally and empathetically far than some abstraction of numbers. This many people were killed. You're not seeing the people being killed. So, or the misery of the migrants. So it really depends on, do you want abstractions? Do you want realism in any world, virtual or on paper? It really depends on what you want it for. Now, that said, people doing metaverses and so forth or any kind of CG are aware that the human visual system and auditory system already filters a lot of information. So you can save bandwidth by saving that, by condensing the information, and people won't miss anything. So, but there it studies more of perception than cognition. And I think that work has affected CG a great deal of what information can people process. So, because there's no point in including expensive information that people aren't processing. But the same goes if people really need abstract information and not the ultra real, then put that in. It's not necessarily easy to know how to abstract. I mean, it's same with writing. It's not easy, it's hard, it's work. So I hope that helps.
Thank you. There's another question that kind of taps into what does this extend to or generalize to by Timothy Hubbard, which asks to what extent the spatial effects that you're describing are bound to being visuospatial. So you used visual stimuli mostly, but do you have any data or speculation regarding perhaps analogous effects with auditory or other types of non-visual stimuli? To what extent are the effects you describe necessarily visual as well as spatial?
So that's an excellent question. I wish I could investigate. I had a graduate student for a long, long time who was head of access to people with disabilities at the Metropolitan Museum of Art, and it was studying cognition more or less for that reason. She herself was remarkable. She was visually impaired, but a brilliant art historian and student of art appreciation. So I was full of admiration for her, but she had a very intense job. So she had planned and made contact with people with an institution in New York that helps blind people. And the idea was to rerun those gesture studies of environments with blind people, giving the stimuli auditorily and looking to see if they gesture. And she took the computer, we developed the stimuli, and I haven't seen her since. And that was many, 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 many years ago. And I haven't had the opportunity to study blind people since. So it's a big disappointment. However, Susan Golden Meadow and Jana Iverson have studied blind people. And children who are blind from birth, when they talk, gesture, especially when they're describing spatial situations. And adults, when you ask them, blind from birth adults, when you ask them to give directions, they gesture those directions. So they've never seen. Their representations of space are spatial. Blind people navigate by sound, by the texture of their feet. This I have been informed about from talking with people who work with blind people and who prepare stimuli for blind people, visual stimuli or tactile stimuli, visual for people with very low vision, but some, and unable to read, but able to see big shapes. So these people will tell me that blind people navigate using smells, using wind, using texture on the ground, using a kind of perception of how far they've gone, which are all things that we use, but maybe not consciously. I mean, I've become self-conscious about using them now. and I use them. I know I'm using them all the time. I get towards Central Park walking in New York, and I know in the winter the wind's going to pick up. It comes rolling across the park, no buildings to stop it, and it hits me. So I'm prepared. So we are using these other stimuli to navigate besides visual, and blind people certainly use them. So that is, it's not approved, but it's an argument by bringing in other forms of data, of research that indicate that these things are spatial. Now, people who are sighted are probably more reliant on the visual than on these other modalities, but there's work showing that there's early adaptation of brains of people born without sight or born deaf, where the brains are adapting and picking and being used for other modalities than the modality that they were intended for. So I think there is a variety of evidence that can be brought. Some of it is the gesture studies that I showed you, where people aren't looking at their hands. They're just making the movements, and it's in their bodies, spatial motor. If I ask you, and this is different for German speakers than Americans, where's the X key on the typewriter? You usually make a movement. So it's encoded in the movements you make. It's not visually encoded anymore for fast typers. And there are many situations like that where people are imagining a movement in order to come up with the information.
Great, thank you. Yeah, Timothy, thanks you in the chat as well for the answer. So we've already reached the end of our time. Thank you so much for sharing all these interesting thoughts and the examples that to me are all very intuitive, so things I've experienced. And I was pointing at my X key while you were asking. So yeah, thank you so much, Robert. There's certainly been a lot of interest, and people have also commented and thanked you for the talk. And they're doing this right now in the chat. So unfortunately, we can't see the audience and we can't hear them clapping, but yeah, we can imagine these actions.
And thank you for being a patient audience and for excellent questions and a wonderful introduction. It's been a pleasure.
Great, thank you so much. So we'll have the next One World seminar in 4 weeks from now, on October 19th. We'll have Carla Evans, and she'll talk about all that one sees in a blink of an eye, from natural to radiological images. So we'll stay with some visual stimuli. And the registration is already open. So on the Psychonomic website, you can already register for this seminar on October 19th. So I hope to see many of you then. And thank you again so much, Barbara, for this interesting talk today.
Bye-bye.